Hello ISACA friends, I'm very happy to have you here. Today we're going to explore a controversial question. Does blockchain mean the end of auditing? Over the next 50 minutes, I'll show you practical examples from how blockchain works, how to approach audits of systems based on blockchain technology, and leave you with a toolkit you can apply.
Have a look at some more information about me. I would like to add that I've been an auditor for over 20 years, mostly in classic compliance focusing on controls, vulnerabilities and information security, business continuity, GDPR, cybersecurity. Almost 9 years ago, I'm interested in blockchain technology. For me, it was a natural next step. As this technology developed, I saw not only innovations, but also new threats and the need for proper assessment and auditing. Here is the plan of my talk. First of all, I will tell you what blockchain is, about implementations, where it is used, about ecosystems and attributes. Then, I will move on to digital governance, from traditional oversight to on-chain assurance. After that, we'll talk about the new role of the auditor and auditing blockchain, tools and workflows. Finally, we'll see FTX case study and conclusions. So let's get beginning. Blockchain is a world in which transactions are transparent, immutable, and automatically verified by a decentralized network. In this perfect world, technology makes sure that all records are true. In such a place, we might think that we don't need auditors anymore. Why ask someone to check the data when the system already ensures that it is correct and operates 24 hours a day? Blockchain gives us fast, resilient, and verifiable rails, but with a trade-off. You hold the keys, and most actions are irreversible, so proper controls and oversight are critical. All started in 2009 when the first block called the Genesis block was built. A few months earlier, Satoshi Nakamoto published a white paper that included the idea of new electronic cash system based on peer-to-peer network without a trusted third party. Satoshi concluded theories like economy, game theory, cryptographic network theory. The white paper is available to read at bitcoin.org. Satoshi is up until now an anonymous person. Of course, blockchain has developed most in the financial sector. Here are some examples of physical financial institutions that have decided to put their resources and processes on the blockchain. Among them, BlackRock, first tokenized fund on a public chain, Ethereum. JP Morgan, payments greater than $1 billion per day via JPM Coin. Swiss Digital Exchange Switzerland, digital bonds. Blockchain never sleeps. Transactions are constantly being carried out around the world. You only need the internet to use it. Here's some regulation of blockchain in the US. Have a look. As you can see, crypto is very important in the United States. In 2025, the US made a clear shift. First, Executive Order 14,178 set a pro-innovation tone, no CBDC, and a plan for a federal digital asset framework. Then the Strategic Bitcoin Reserve and the US Digital Asset Stockpile were created, a signal that digital assets are considered as a national resource. In July, the Genius Act became law. It requires licensing, full reserve backing, regular attestations, and stronger disclosures for payment stablecoins. This is a new hard audit criteria which verify not only KYC, AML, and travel rule. It signals the US now sees digital assets as part of its national financial toolkit. By the way, now we are currently working on Cryptocurrency Act in Polish Parliament on MiCA. EBASI is the EU's public trust network built on blockchain. It is not a cryptocurrency network. Government bodies run the nodes. EBASI is used to issue and verify digital credentials, for example, diplomas, licenses, or company data, using W3C verifiable credentials. A citizen or company holds the credential in a wallet. A verifier checks cryptographic proofs. Personal data is not written on-chain. The ledger acts as a trust registry and an audit trail. Auditors should focus on issuer authorization, key management and rotation, revocation, and alignment with EIDAS 2 via the EUD wallet. In Poland, NASK supports the implementation and invites public bodies to run nodes. Next, I will show how EUD wallet and EIDAS 2 change controls and assurance. Today, every app asks us to create a new identity. We don't really know what happens to our data. With EIDAS 2, the EUD wallet gives us a secure way to reuse identity across the European Union. The flow is simple. An issuer, for example, a government office or university, gives me a verifiable credential. I keep it in my wallet on my device. When I need the service, the verifier checks cryptographic proofs. I use selective sharing. I share only what is needed, like marriage or license valid. Personal data is not written on chain. The blockchain can hold trust lists and revocation status, so verifiers can check if the credential is still valid. Identity blockchain can provide a secure way to manage digital identities. This could simplify the process of verifying identities online, making it easier and safer to access services like online banking, e-commerce, even government services, or rent a car. Blockchain can support voting by keeping a tamper-evident record. It allows end-to-end checks of the process. It may reduce some fraud risks and speed up the tally. This is useful for remote and overseas voters, but the biggest risks are off-chain. A voter's phone can be infected with malware. Voters can be coerced or paid to vote a certain way. Blockchain is a shared log that shows if something was changed. It helps us track items over time. Example coffee, each scan adds origin, batch, and location. This gives more transparency. But for audit, the risk is off-chain. The ledger cannot prove this is the same physical coffee. So we test real-world controls. Who can write data, serialization, like RFID, NFC? Do IoT sensors record readings we can verify? Is chain of custody clear at each handoff? We also check data bridges, oracles, integrations. Do records match documents? Blockchain gives the trail. Physical evidence still decides. Let's now look at standardization. ISO is the International Organization for Standardization. ISO TAC 307 has worked since 2016 on blockchain and DLT. It covers vocabulary, reference architecture, and governance. Is currently working on around 30 standards. ISO 22739 standardizes terms, so we are talking. ISO 23257 gives architectural views, components, roles, and flows. That helps us attach controls, access keys, logs, and integrations. ISO TAS 23635 sets governance principles, roles, responsibilities, risk, compliance. In short, ISO tells us what to check and how to describe it. As you see, we have TR, PAS, TSTR is technical report, a review or guidance, not a full standard. PAS is publicly available specification, a fast spec, often a step toward a future standard. TS is technical specification, more mature than PAS, but still not a full international standard. Here is another standardization organization, IEEE, and some standards they have created. These are technical standards about tests, procedures, and so on. IEEE is the engineering side, tests, procedures, and acceptance. IEEE 3201 sets access control requirements across chain layers. IEEE 2 140.5 describes crypto custody architectures and operating models. IEEE tells us how to test and when to accept a system. Beyond ISO and IEEE, there are useful guides. NIST 8202, a technology and risk overview. AICPASOC for supply chain, helpful for traceability and supplier controls. ISACA blockchain audit program, checklists and audit procedures. OWASP application and smart contract security view, industry frameworks, good for platform-specific risk but less universal. In practice, use ISO for the framework, IEEE for testing, and these guides as add-ons for your use case. In short, I will tell you how transactions get on-chain, about consensus mechanism, smart contract, oracles, and introduce the types of blockchain. The goal is simple: understanding blockchain and see key risks. Blockchain is a data registry called digital ledger containing information about transactions or other digitized events that have been carried out through the network between its users, actors, for example, citizen, office, institution, company, device, or IoT. Each block contains an agreed set of information about completed transactions in a fixed unit of time, for example 10 minutes, and is inseparably linked to the previous block via cryptography, forming a chain of blocks. A blockchain is a growing list of records called blocks, linked using cryptography. Blockchain is not a database for this reason. We can only record data, we cannot change it. If we change our mind when the transaction is in on blockchain, this is not possible because we can only write a data at the ledger. In database, we usually do all processing operations: create, read, update, delete. Each block contains a cryptographic hash of the previous block, timestamp, and transactions data, generally presented as a Merkle tree. Let's go through the process of recording transactions in the blockchain network. How blockchain works. Let's describe this. The user or actor initiates a transaction. This could be anything from sending cryptocurrencies like Bitcoin to another user, recording a contract, or even casting a vote in the election. When the transaction is initiated, it needs to be verified in blockchain network. This verification is done by a network of computers, also known as nodes. These nodes confirm the details, including the validity of the transaction and the status of the participants. After verification, the transaction is added to the block. Basically, it is grouped together with other verified transactions into a block. Each block has a specific capacity, and when this capacity is reached, a new block is created. Before the block can be added to the chain, it needs to be given a unique ID, known as a cryptographic hash. You can imagine a fingerprint, for example. This hash is created from the transaction data in the block and is unique to the block. It also contains the hash of the previous block in the chain, creating a link between the blocks. After block is added to the chain, it has to be accepted. The nodes in the network needs to reach a consensus. That block is valid. This is done through a process known as mining. In some blockchains, like Bitcoin nodes, solve complex mathematical problems. Other blockchains use different consensus mechanisms, like proof of stake. When consensus is reached, we have the complete transaction. The blockchain has now updated, and everyone in the network can see the new block and the transactions it contains in it. Blockchain is a transparent, unchangeable, decentralized digital ledger that records transactions across many computers. Consensus mechanism is a mechanism for validating transactions and attaching new blocks to the chain, performed by the software of the nodes in the blockchain network. In traditional solutions, to confirm the transaction, a third party must appear to determine which version of events is current. In blockchain, this is not needed. Consensus is an agreement between network nodes containing a set of verified transactions recorded in a block. Consensus means that the majority of network participants must agree on the new block or transaction. A consensus algorithm is a mechanism that allows all network participants to agree on the current state of the network. It ensures that each new block represents a single version agreed upon by all nodes. The goal of the consensus algorithm is not only to reach a common agreement, but also to promote collaboration and cooperation, ensure equal rights and responsibilities for each node, and include all participants in the consensus process. Without consensus, users would see different truths that would make the system easy to attack and to defraud. Let's talk about consensus mechanisms in blockchain projects. Do you know how many types of consensus mechanisms exist? There are more than 80 types that have worked for at least 2 years. Those you see on the screen and many more with creative, fancy names and meanings. But the two most important to remember are proof of work and proof of stake. Each mechanism has pros and cons. The right choice depends on the needs and goals of the blockchain network. After Bitcoin, Ethereum popularized smart contracts. Ethereum now uses proof of stake. What is smart contracts? A smart contract is a small program on the blockchain. It runs automatically when rules are met. After it runs, the transaction cannot be changed. Like a vending machine, you pay, then it gives you the item. Why smart contracts are useful? No need for banks, lawyers, or middle people. Works even if people don't know or trust each other. Used for many things: buying and sending goods, paying when goods are delivered. Example, a company buys parts. When the supplier sends them, the smart contract automatically sends the payment. Smart contracts are programs on the blockchain. They run by rules and then cannot be changed. They are isolated from the internet. They cannot fetch prices or weather on their own. They use oracles to bring outside data on-chain. Key risk: garbage in, garbage out. Bad, late, or manipulated data can break the contract. Smart contracts remove middlemen but add coding risk. Audit checks, code review, tests, and match to business logic. Treat them as automated business processes. Oracles bring outside information to the blockchain. They are very important but also a weak point. If an oracle fails or is hacked, the system can become unsafe. Auditors check who controls oracles, backups, and incident response. It is worth mentioning an interesting Polish project called Redstone, which is gaining popularity. Redstone is a modular oracle that feeds data on demand, lowering costs and supporting many assets across over 70 networks. Digital assets are values created and stored in digital form. They include cryptocurrencies, NFTs, stablecoins, digital bonds, and other tokens. Tokens can also represent real-world things like real estate or art. These assets can be traded on blockchain platforms. Blockchain technology can take different forms depending on the architectural model and access rules. These include public, permissionless. Anyone can join, see all data, and take part in consensus. For example, Bitcoin, Ethereum, audit view, full transparency but high AML risks because users are anonymous. The second is private permission. One company controls who can join and see transactions. For example, Hyperledger Fabric, Corda. Audit view, main task is to check access, permissions, and internal rules. The third is consortium, hybrid, run by a group of companies like banks, combines elements of public and private blockchains. Audit view, focus on cooperation agreements and risk of collusion. It is important to understand that there is no single type of blockchain. Depending on business needs, we can choose from different models, each of which has fundamental implications for auditing. As you can see, the blockchain landscape is very big and more. Auditors have many areas to check. In this white paper, the ISACA AICPAO and CIMA Joint Blockchain Working Group assigns blockchain risk to 5 domains: governance, who decides, who approves, who can change rules; infrastructure, nodes, networks, cloud, bridges, security hardening; data quality, privacy, retention, reconciliation with off-chain records; key management, key generation, storage, rotation, recovery, and access rights; smart contracts, code review, testing, upgrades, admin powers, and Oracle inputs. The paper lists risks with IDs, domain tags, names, and descriptions. In the world of Web3, customers not only buy, but also co-create the brand, store their identity in digital wallets, and express their loyalty in DAO votes. In decentralization, governance moves from boardrooms to protocols, treasuries, DAOs, and code. We still care about accountability, compliance, and resilience. 2 sentences about maturity web. Web 1 was read-only. Web 2 was read-write under platforms. Web 3 is read-write-own, with wallets, tokens, and DAOs. Centralized versus decentralized. So how do we govern data today? Centralization is best uniform rules. Decentralization wins when many parties must trust one shared state. On one side, the traditional world, ledgers and central databases. On the other, Web 3, distributed systems without a central middleman. Transactions are confirmed by network consensus, not by a third party. Bigger networks can be harder to attack, in theory. So, if tech is a truth machine, why keep auditors? Because trustless does not mean no trust. It means we shift trust from banks to code, consensus, governance, and people. Talking about blockchain, I must say about difference organization management. In traditional organization, we have top-down hierarchical structure with lots of management levels, lots of informations, lots of decisions. Susceptibility to corruption and employment contracts is an organization managed in whole or in part by decentralized computer program, with voting and finances handled through a blockchain. In general terms, DAOs are member-owned communities without centralized leadership. Blockchain technology is revolutionizing not only how data is stored, but more importantly, how decisions are made. This leads us to a key distinction that every auditor must understand: the difference between on-chain and off-chain governance. Traditional corporate governance is familiar to us. Decisions are made by supervisory boards and management boards. They are documented in minutes, but the process is susceptible to human interpretation, politics, and informal influences. On-chain governance is a radical paradigm shift. In this model, the rules for changes to the blockchain protocol are built directly into its code. Stakeholders, typically token holders, vote on proposed changes. If a proposal receives the required majority, smart contracts automatically implement the change in the system. The process is formalized, fully transparent, and automated. Anyone can see who voted, how they voted, and what the outcome was. However, this is not the whole picture. Off-chain governance exists in parallel. This is the human social dimension of the decentralized world. It includes discussions on internet forums, social media, teleconferences, and community meetings that lead to the formulation of proposals, which are then put to an on-chain vote. This is where social consensus is built before it is technologically confirmed. When we audit blockchain, we need different categories of tools. First, compliance and governance frameworks. They help us align blockchain with existing regulations and standards. Second, block explorers like Etherscan or BSC Scan. These allow us to see transactions, wallets, and blocks directly. Third, AML and KYC tools such as Chainalysis or Elliptic. They de-anonymize wallets and trace suspicious flows. Fourth, node and infrastructure monitoring, tools that show us performance, uptime, and anomalies in the network. And finally, smart contract analysis tools, like Mitefx or Slifer. These help us detect vulnerabilities in the code. Together, these categories form the practical toolkit of a blockchain auditor. Before we dive into tools, let's remember that auditors need governance first. That's why ISACA created the blockchain framework and program. It helps align blockchain audits with global GRC practices. Then we have compliance and external assurance providers like CertiK or Consensized Diligence, AML tools like Chainalysis or Elliptic, and technical analyzers like Slither or Mythix. How I audit a smart contract. Always verify code against intended business logic. Use automated tools. Slither and MythX and manual review. Re-audit after upgrades, forks, or Oracle changes. Monitor contracts continuously for anomalies. This audit program takes audit components from ISACA's blockchain framework, governance infrastructure, data management, key management, smart contracts, and provides auditors with the control objectives, and testing needed to evaluate blockchain. This book is free for members. This example ISACA's controls for blockchain data. We check data integrity, timestamps, and how we treat orphan or unconfirmed transactions. We also match on-chain data with off-chain records. Tests are simple. Use a block explorer to verify inputs and outputs, check a UTC time, confirm multi-sig approvals, and curb evidence. These controls align with COBIT, NIST, CSF, and ISO 27001. Block Explorer is a type of tool that can provide information on the contents of individual blocks and transactions that are found on a blockchain. Etherscan.io enables you to look at the Ethereum blockchain. Today, it is common practice to pay salaries in cryptocurrency or to provide collateral for deposits. You can go yourself and look to the blockchain to see if a transaction has been confirmed or not. This is very different from example, if somebody sends you a payment from a bank. You must go to your bank and find out if a check has created or not, but when you actually get to go to a Block Explorer, you can check a transaction confirmation to make sure that transaction has actually happened. Let's summarize our argument. Blockchain provides a powerful, transparent, and immutable ledger, but this ledger is only part of a larger system. A system consisting of code, cryptography, and most importantly, human management. Blockchain does not eliminate auditing. It transforms its role. We move from paper to systems and compliance to continuous digital oversight, real-time monitoring, on-chain and off-chain analytics, code audits, and AI, linking DAO governance with legal requirements. Just as the internet evolved into Web 3, auditors must evolve into Auditor 3. In a decentralized world, the real value of the auditor lies in connecting technology, governance, and trust. Skills to focus on. On-chain reading. How to open a Block Explorer and follow a payment step by step. Smart contracts basics. What ERC20 and ERC721 mean. Who has which role and when upgrades happen. Web3 safety habits, wallets and keys first. Know what mixers, bridges, and oracles do. Why a 51 attack matters. Rules to know, MECA, DORA, NAIS2 in the European Union, United States stablecoin rules, and the travel rule. Let's talk about FTX. Proof that blockchain is not enough without oversight. Just look at the catastrophic collapse of the FTX exchange in November 2022. We're talking about a cryptocurrency-based platform valued at $32 billion that broken down almost overnight, with billions of dollars of customer funds simply vanishing. This event shook the foundations of the industry and punctured the narrative that technology by itself guarantees integrity. Here, a key paradox emerges. The term trustless in the context of blockchain is one of the greatest misunderstandings in the business world. It does not mean there is no need for trust. It only means we no longer have to trust a central intermediary, such as a bank. Instead, we are compelled to place enormous trust in something far more complex, the system itself. We must trust the integrity of the code, the reliability of the consensus mechanism, the robustness of the governance framework, and most importantly, the ethics and competence of the people who control that system. The fall of FTX was not a failure of blockchain technology per se. It was a spectacular failure of corporate governance, internal controls, and human integrity. The need for trust did not disappear. As we conclude our journey, let's return to the fundamental misunderstandings that often cloud the discussion about blockchain and auditing. It's time to debunk a few myths. Myth 1. Immutability means no audit. Records can't be changed, but bad inputs stay forever. We audit input quality and the processes that create it. Myth 2. Data is public, so everything is clear. Transparency is not equal to understanding. On-chain data is pseudonymous and complex. We need tools and skills to turn it into risk signals. Myth 3. Decentralization equals no oversight. No central boss doesn't mean no control. We audit the on-chain governance and off-chain people and processes. Myth 4. Smart contracts audit themselves. Code only does what it's told. We must review logic, oracles, upgrades, and compliance before and after go live. Practical tips for auditors with no experience in blockchain technology. Familiarize yourself with the basics of blockchain. Blockchain Explorer, cryptocurrency wallets. Participate in basic training on smart contracts and DLT technology. Analyze available audit reports and case studies to understand common risks and errors. Use available tools and platforms to simulate blockchain audits under controlled conditions. Keep track of regulatory changes and industry standards. As you can see, blockchain is an exciting new technology and a big challenge for us, auditors. This is the end of my talk. Thank you for your attention. If you have any questions, please contact me with LinkedIn.